and it was, let's say it was negative saturation per minute, and it was -2, and it was dropping every two every minute, then you know that in the next 5 minutes, he's gonna be 10% down, even though the mean was acceptable within range. Those are the kinds of things you have to start thinking through. And then feedback. The feedback, you have to decide whether you go incremental changes from one setting to another, or whether you have continuous feedback. I don't know how those work. I don't know how the valves work.
You guys might know more than we do about that.
Unlike the motorized valves.
Mm-hmm. In terms of whether you just set them to a certain opening, or
I'm not sure if they have different like degrees of, or different diameters, or if it's just.
well, what I used to tell people about the software, everybody was all upset about where we started, what dose we started with. And what I kept telling them, within 2 hours, it didn't matter, because the software went there. It goes to the right spot. What you didn't, in the case of insulin, you didn't want to start high. That's the one thing you didn't want to do, because you didn't want the second blood sugar to be in the basement. So you wanted to start low and work your way up.
So eventually it just works by itself.
It auto regulates. So if you have a valve that just opens by a certain amount, you know, maybe you're doing this on 15-minute cycles, and within an hour it's opened up. And if you started real low, it opened a bigger amount the first time. And the difference in what I had to do, what I was trying to do, is I was generating a dose for the nurse to read the dose and to operate. So I was just trying to get the nurse out of the middle of the calculation. In your case, you actually want the software to control the oxygen, so that everybody's you want everyone out of the equation, so that the software is doing what the doctors would do.
So you guys with this, for your information, are measuring glucoses every hour initially. And then sometimes you cut back to every 2 hours. This would potentially need to be more frequent than that. How frequent, I don't know. It's a lot easier to measure this because you can get a continuous output. You can't do that, at least easily, with glucose.
And the chances of you doing it too often, making changes too often, are actually slim. I don't think if somebody had normal saturation, I don't know that you really want to be making changes more than every 5 minutes or 10 minutes, but that's
right.
And I had to limit the changes because insulin is so dangerous. We had to limit how much we increase each time. We just didn't want to go crazy.
And was that relative to proportion?
Yeah,
It was a drop.
It was, yeah, and when the drop was at this limit or this way or at this limit or higher, it was maxed. And so whatever the max percent was, we only allowed 20% or 25% change at any one time. You could change 100% at one time because the side effects of excess oxygen are nil. You
Right.
would probably start
Yeah.
wide open
And turn it down.
and turn it down unless wide open is dangerous.
Generally not. Yeah. Generally not. It's just a matter of conservation of the.
Of course, if you start wide open, you're running the risk of wasting oxygen you're trying to save.
Right.
That could possibly only be for a few minutes.
The other side of the coin is you're starting with people who are on no oxygen. You probably could start with 2 liters a minute and then go up or down from it. You start in the middle of the range and go up or down depending on the patient's response and be smarter. Because if you started at 20 liters a minute, it could be an hour before you got down to 2 liters.
Right, and that'd be a waste.
That'd be a waste. But that's the kind of thing you think through. Those are, you start making lists of things that affect this process and output effects. And lists like whether you're connected, whether the machine is connected, whether there's electricity. Of course, there's no electricity, there's no computer, so that's easy. What the software does when there's no electricity. You know.
Well, for ambulatory patients, they'll probably have a gizmo that's built into their shoe that can convert mechanical energy into electrical energy and keep the whole system running. Right?
Have I generated enough questions so far?
I think so. It's a lot to think about, yeah.
That's a lot to think about.
So, for our, I guess, electronics control, you suggest just a small computer?
Oh, yes. You're not gonna use, what kinds of, what are you programming? Any of you use any of the languages other than Excel or?
We
I've
really
not-
don't know
I've
much
never-
about that, yeah. Christian knows the most.
Yeah,
I really don't
Christian's
know
our
much.
programmer.
We have some people that could do
Can
that.
you
I
do
think.
something like this through Excel?
I think so. I think so. But that would be the easiest thing to do. Because the higher the level of language, the higher level programming language, the easier it is, it speaks English. You look at the equation, you know exactly what it means. Just, and the difference between programming and spreadsheets is the spreadsheet focuses on the data. In programming, the focus is on the equation, which is related to all the other stuff, which is harder to interpret as a beginner. Spreadsheets are easier to start with because the focus is on the data, and you can look at the square and you can see exactly what the equation is because you wrote it down. And all you do is take the equations you write down when you outline your project. And look up feedback control in Google, and there's symbols that people use for feedback control, positive, little symbols for feedback, and you just data in and then answer it out. And you just need to walk through the process, and I'll be happy to help you with that. And I'll be happy to look to see what kind of valves. I designed a one machine once, and it actually had working with controlled valves off of that kind of computer. But it wasn't off a spreadsheet, it was off of BASIC. I used BASIC language. I haven't done BASIC for 20 years.
Yeah, I know where this goes. You might need a programming consultant.
Well, I think
Yeah.
we have one, Mr. Shockley, though.
Mm-hmm.
Yeah. So I think we can get the help when we're
Mhm.
there, it's
Yeah.
just a matter of time.
Sounds like at this point, some of the stuff will need to be done, I'd say, in the limits.
Yeah.
Well,
Look into
that's-
a little bit.
We can
more
start
about,
with the data, see how it works.
Well,
the
being
half-life
realistic
stuff.
right now.
And, choosing monitoring frequencies and all that sort of thing.
That's a good start. Another thing, if you want to know how much potential, the engineers who design these things are always forced to answer the question, how much are you going to save? Where's the money? Because if you're going to add expense by adding something to the patient's care, in this case, like a machine, you've got to have something that comes out of that, either improved care that's worth something, worthwhile, or reduce costs to pay for the machine you just added. And the oxygen, we're talking about a program that would fit in 1/10 of your phone on a chip. It just would take no space at all. Because the reason I say that is because it's almost an on-off. Because the half-life is so fast, and we're not talking about complicated things that we have to worry about high end or low end. We just have to respond and have alerts. And so in doing that, you're talking about pretty simple software. What you need to know.
Yeah, if you can make